Okay, so here we're looking at calculation of the future value and the present value of money. All right, first we're going to start with future value calculations. Right, remember the time value of money concept. Money has different values at different time periods. Okay, so this is the formula for the future value. Okay, future value equals present value 1 plus R. RI is just the rate that we'll be using to the power T. Other books are going to see to the power N. Okay. So this formula, it's got from the formula for compound interest. If you remember the formula for compound interest, A equals P 1 plus R to the power T. All right. Since compounding interest, N represents the number of compoundings. Yes. So this formula for the future value is similar to the formula for compound interest. All right. So I want on your papers you write this formula down because the one that we're going to use to calculate these questions here. So we'll start with the first question. The first question is saying you invest 10,000 at an annual interest rate of 8% for 5 years. What will be the future value of your investment? So colleagues, you put in a 10,000, let's say in your bank, okay, and the interest at your bank is 8%. You want to know, okay, after 5 years, how much am I going to have? All right. So for this question, we want to find the future value. Okay. Our present value is this 10,000 kwacha, how much we're investing now. So it's a PV, it's 10,000. Our rate R is going to be 8%. Convert it into a decimal, so that's going to be 0.08. Our time T is going to be 5 years. Yes. So now we want to find our future value. So we just put our formula here. Future value equals the present value, 10,000, open brackets, 1 plus R, this 8%, so put 0.08 to the power 5. Okay, so we're going to say 10,000 multiplied by 1.08 to the power 5. So we get our calculators. So 1.08 to the power 5. That's 1.469. Multiply by that by 10,000. We get 14,693. Watch. 14,693.28. Okay, so after 5 years, this is how much you're going to have in your bank account. Yes. Any questions? Any questions? Right, where you're not clear, remember you can ask me, okay? All right. So we're going to go to the next question where now we've got interest that is compounded. Colleagues, do we know what compounded interest is? When we talk about compound interest, what do we understand when we say compound interest? Because we've got simple interest and we've got compound interest. So what is compound interest? If I may ask, Madam Sarah or Madam Precious, Madam Bethel, I don't know if it's Mr. Cholwe. Okay, compound interest is the interest that's calculated on the principal, the money you put in, and it's also calculated also on the interest you earn. Okay, so you'll be earning interest, and on that interest you earn more interest. Okay, interest earned on interest, basically. That's what compound interest is. Okay, simple interest is only calculated on the principal, the amount you put in, but compound interest is calculated on the principal and the interest. Okay, so here 5,000 is invested, 6% interest, compounded semi-annually for 4 years. What will be the future value? So I'm going to say present value, PV, is how much you're putting in, 5,000. Our interest R is 6%. And time is 4 years. Okay. So now, when interest is compounded, this formula changes slightly. It becomes future value equals present value 1 plus the rate over n, which is the number of compoundings, to the power the time times the number of compoundings. So put t times n. Okay. So when we say interest is compounded semi-annually, it means that you'll be paid interest twice a year. Okay? You'll be paid interest twice a year. Now, that interest rate of 6%, you won't be paid 6% after 6 months, 6% after 6 months. No. That 6% interest will be divided by 2. Okay? So after 6 months, you get paid interest of 3%. And after another 6 months, you get paid interest over um, think 3%. Okay. So each year you'll be paid interest twice. Okay. So in those 4 years, you'll be paid a total times of 8 times. Okay. Year one, you'll be paid interest 2 times. Year two, you'll be paid interest 2 times. Year three, gain interest 2 times. Year four, get interest 2 times. So in total, you'll be paid total of interest. You'll be paid total of 8 times throughout this 4 year period. Right? So that's why we're dividing the rate by the number of compoundings. Okay, this 6%, as I said, after 6 months, you're paid 3% interest. After another 6 months, 3% interest. All right. Yes. So when you hear interest compounded semi-annually, then n equals 2. Okay. If it says the interest is compounded quarterly, then n equals 4. Okay. If the interest is compounded monthly, then n equals 12. Okay. So this is what we're going to do now. Tabulate. So our present value is 5,000. 1 plus, so say 6% divided by 2. Okay, we'll convert it into a decimal in the next line. Then the time, 4 years multiplied by 2. So here we're going to have 5,000, open brackets, 1 plus. So 6% divided by 2, that is 3%. 3% in decimal form is 0.03. 4 times 2, that is 8. So we're going to say 5,000 multiplied by 1.038, 1.03 to the power 8. So we're going to say 1.03 to the power 8. That is 1.22, 1.26 times 5,000. You get 6,383. 0.85. Okay. So this is how much you're going to have after 4 years, colleagues. Okay. If you invest money and the interest is compounded semi-annually, okay, invest the 5,000, an interest rate of 6%, which is compounded semi-annually. After 4 years, you're going to have 6,383. Okay. Yes. The question now I might ask you is, so how much have you earned in interest over these 4 years? If I may ask, from this tabulation, colleagues, how much have we earned in interest over these 4 years? You just subtract this amount from how much you put in, 5,000 here. So that you have earned like a 1,333 kwacha. Okay, that's how much you've earned in terms of interest. 1,333. Any questions, colleagues? All right, wonderful. Now let's go to the present value calculations. All right, here, because in those calculations which we were doing earlier on, we we're trying to find out how much we'll have in the future. But now here, I want to find out money which we're receiving in the future. How much is it going to be today? All right. This is what we call discounting. Okay. Remember this word, colleagues, discounting. Converting money which is in the future into today's value. Right. That's what we call discounting. So first, let me show you the formula for the present value. Okay, so formula is present value PV equals future value 1 plus R to the power negative t. Okay, 1 plus R to the power negative t. Okay, or other books you see it written this is the future value over 1 plus R to the power t. Okay, you can use any of the two. Okay, you will not be penalized. Okay. Yes. So let's look at our first question here. Okay. You are promised a 20,000 to be received 6 years from now. The discount rate is 7%. What is the present value of this amount? So basically, after 6 years, you receive a 20,000. So now that 20,000 which you receive, you want to find out what is its value today. All right. So here, our future value is this 20,000. All right. Our discount rate, R, is 7%. The time is 6 years, T 6 years. So we solve now. So say present value equals our future value 20,000 multiplied by 1 plus our discount rate is 7%. So we convert it into a decimal 0.07 to the power -6. 1 plus 0.07, that's 1.07 to the power -6. So we're going to say 1.07 to the power -6 that is 0.66 times 20,000, you get 13,326.84. Okay, colleagues. So that 20,000 you receive in 6 years from now, to its today's value, it is 13,326. Any questions? All right. I'll move to the next one now. We'll bring in compounding now. You expect to receive 8,000 in 2 years. If the interest rate is 6% compounded monthly, what is the present value today? Okay. So if you want to have an 8,000, okay, in 2 years' time, okay, and your bank is saying, okay, well, the interest is compounded monthly and the interest rate is 6%. Basically, how much should you invest today? Okay. So here now we've brought in compoundings. Okay. So as I said, anytime there is compoundings, just remember, divide the rate by the number of compoundings and multiply the time by the number of compoundings. Remember that, okay? Anytime there is compoundings in these questions, divide the rate by the number of compoundings and multiply the time by the number of compoundings. That is the trick that you need to always remember. So this is what we're going to do here. So as I said, when there's compounding, our formula just adjusts, becomes present value equals future value, in brackets, 1 plus R over N multiplied by N times T. All right. So when interest is compounded monthly, so it's basically every month you're going to be paid interest. Okay. So this 6% has to be spread out through 12 months. Okay. That's why we're dividing R by N. So you're going, so when you say R divided by N, 6% divided by 12. Let me convert it in 0.06. Since 6% is 0.06, 0.06 divided by 12. You get 0.005. Okay, every month, this you'll be paid interest of 0.005 every month. Okay, 0.05. Okay. Then our time, which is 2 years, we're going to multiply it by 12. So 12, which is N. Okay. When interest compound monthly, N equals 12. Forgot to write this down. Yeah. So 12 times 2 now gives you 24. So you're going to be paid interest 24 times in this 2 years period. Okay. So now we can just substitute here into our formula. Our future value, 8,000. 1 plus our rate divided by n, we got 0.005. So here 1, 0.005 to the power negative 24. We're going to put here the negative here, to the power negative 24. So we're going to say 8,000. 1 plus 0.005, you get 1.0005 to the power negative 24. You get 0.887. 0.887 times 8,000. You get 7,097. 7,097 point, we say 0.49. Right. So basically, in simple terms, what we're saying is if you invest today a 7,097 kwacha, where in a bank or in investment where the interest is compounded monthly at a rate and the interest rate is 6%, you're going to have an 8,000 after 2 years. Any questions? Okay. So as I said, this topic, you can use it for your day-to-day lives, all right? All of us have savings accounts, okay? It depends what the rate is at your bank. So you can ask yourself questions like, okay, if I want to have 100,000 in 5 years' time, how much should I put into my savings account today? Then you just use this formula here, and you will see how much you need to put in. And after those number of years you expect to have 100,000, right? So these computations, even businesses, they use them. Okay, even businesses use these computations, and as I said, it's time value of money topic. We're going to see it throughout managerial finance.